aspirants, welcome to Magic World of Physics. In this video, we're going to discuss about some questions from quantum mechanics which is asked in various exams like GATE, BARC, JUST, DIFFER. Hope this video will be helpful for your coming BARC exam 2026. Without any further delay, let's get started. The first question is, a particle of mass m in the potential V of x is equal to half m omega square x square for x greater than 0 and V of x is equal to infinity for x less than or equal to 0. The ratio of energies correspond to the lowest level to the next highest level is dash. So here V of x is equal to half m omega square x square for x greater than 0 and for x less than or equal to 0 V of x is equal to infinity. So the graph can be drawn like this, and we know that here energy is equal to n plus half into h cut omega, and here n is equal to 1, 3, 5 etc. That means here n is only the odd values. So for the lowest level, that means for n equal to 1, E1 is equal to 3 by 2 h cut omega, and for the next higher level, that means n equal to 3. For n equal to 3, the energy E2 is equal to 7 by 2 h cut omega. Taking the ratio, that means E1 by E2, we get it as 3 by 7. So here the answer is 3 by 7. The next question is, a particle is scattered from a potential V of r is equal to g delta cube of r. Using the first Brown approximation, the dependence of d sigma by d omega is dash. So here we need to use the Born approximation, and here the potential involves the Dirac delta function. So here in the potential term we can see a value g. G means it is a constant here, so we must include that term in the scattering amplitude equation also. So that we can write the scattering amplitude as f of theta phi is equal to minus mg divided by 2 pi h cut square integral over d cube of r e raised to minus I into k dash minus k into r into v of r. So this is equal to minus mg divided by 2 pi h cut square integral over e raised to minus qr delta cube of r minus 0 d cube of r. By the Dirac delta property, we can write it as this is equal to minus mg divided by 2 pi h cut square into 1. So this is equal to minus mg divided by 2 pi h cut square. So here d sigma by d omega, that means the scattering amplitude is independent on theta and phi. The next question is, which of the following is correct for the phase velocity Vp and the group velocity Vg? In the option C, it is given that Vg and Vp is greater than C, but this is not possible. So option C is wrong. And we know that Vp is equal to omega by k and Vg is equal to d omega by dk. Multiplying h cut on both sides, that means on numerator and denominator, we can write Vp is equal to h cut omega divided by h cut k, and this is equal to E by P. And Vg is equal to d omega by dk. Also multiplying h cut on numerator and denominator, we can write it as Vg is equal to d omega h cut divided by dk h cut, and this is equal to dE by dP. So in the relativistic case, we can write the energy term as E is equal to square root over p square c square plus m square c raised to 4. And Vp, that is equal to E by P, and this is equal to square root over p square c square plus m square c raised to 4 divided by P. And Vg is equal to dE by dP, and this is equal to 2p c square divided by 2 into square root over p square c square plus m square c raised to 4. And this is equal to p c square divided by square root over p square c square plus m square c raised to 4. So therefore Vg is equal to c square divided by square root over p square c square plus m square c raised to 4 by p, and this is equal to c square by Vp. Therefore we can write Vg into Vp is equal to c square. So the option A is wrong. And we know that for free space the potential V is equal to 0. Therefore the total energy E is equal to P square by 2m. Therefore Vp, that is equal to E by P, this is equal to P square by 2m by P, and this is equal to P by 2m. And Vg, that is equal to dE by dP, this is equal to d by dP of P square by 2m, and this is equal to 2p by 2m, and this is equal to P by m. That means Vg is not equal to Vp. So option D is also wrong. So here the answer is B, because for the electromagnetic wave in medium, Vp represents the speed with which the energy propagates. Next question is, Let ket m and ket n denote the energy eigenstate one-dimensional simple harmonic oscillator. The matrix element bra m px ket n is non-zero when. So here for a simple harmonic oscillator P is equal to I into square root over m h cut omega by 2 into a dagger minus a, and x is equal to square root over h cut divided by 2m omega into a dagger plus a. Ignoring the constants, we can write px is equal to a dagger minus a into a dagger plus a, and this is equal to a dagger square plus a dagger a minus a dagger minus a square. Substituting the value of px, we can write Braham px keten is equal to Braham a dagger square keten plus Braham a dagger a keten minus Braham a dagger keten minus Braham a square keten. And we know the property of Bra and ket vector, that is a dagger ket n is equal to square root over n plus 1 ket n plus 1, and a ket n is equal to square root over n ket n minus 1. Therefore, in the first term in the equation number 1, that means Braham a dagger ket n is equal to Braham a dagger ket n plus 1. Ignoring the constants, we can write this is equal to Braham ket n plus 2. And this is not 0 when m is equal to n plus 2. And in the second term, that means Braham a dagger a ket n, and this is equal to Braham a dagger ket n minus 1. And this is equal to, here also ignoring the constant, we can write this is equal to Braham ket n, and this is not 0 when m equal to n. And the third term in the first equation, that means Braham a dagger n, and this is equal to Braham a ket n, and this is equal to Braham ket n, and this is not 0 when m equal to n. And the fourth term, that is Braham a ket n, and this is equal to Braham a ket n minus 1. Ignoring the constants, we can write this is equal to Braham ket n minus 2, and this is not 0 when m is equal to n minus 2. So here, if 1 is to be non-zero, then m should be equal to n plus or minus 2 and m equal to n. So here the answer is option B. Next question is, two-level quantum system has energy eigenvalue E1 and E2. H dash is equal to lambda delta sigma x, where sigma x is equal to 0, 1, 1, 0. The magnitude of first and second order correction to E1 due to H dash is, so here H dash is equal to lambda delta sigma x. Substituting the value of sigma x, we can write H dash is equal to 0 lambda delta 0. For the first order correction, that means for En1, this is equal to Braham H dash ket n. And for n equal to 1, we can write it as E1 1 is equal to Braham H dash ket 1. For the unperturbed Hamiltonian, it is given that the eigenvalue is E1 and E2. So we can write the unperturbed Hamiltonian matrix H0 is equal to E1 0 0 E2, so that the diagonal elements will be the eigenvalue. Then the eigenvector corresponds to E1 is 1 0, that is the column vector, and for eigenvector corresponds to n equal to 2, that means for the energy E2, we can write ket 2 is equal to 0 1. We know E1 1 is equal to Braham H dash ket 1. So the first one denotes the row vector and the second one denotes the column vector. So this is equal to 1 0 0 delta lambda 0 1 0. So this is equal to 1 0 0 delta lambda, and this is equal to 0. And for the second order correction, that means for En2, we can write it as this is equal to summation over m not equal to n Braham H dash ket n the whole square divided by En0 minus Em0. For n equal to 1, we can write it as E1 2, and it is given that m not equal to n. That means here n is equal to 2 and n is equal to 1. So E1 2 is equal to Bra2 H dash ket 1 the whole square divided by E1 0 minus E2 0. So here we need to find the value of Bra2 H dash ket 1. We know h dash is equal to 0 lambda delta 0. In bra2 h dash get 1 means we need to consider the second row and first column. In the h dash matrix, if you observe the second row and first column, the common term is the delta lambda term. So here we can write that bra2 h dash get 1 is equal to delta lambda. So substituting these values, we can write E12 is equal to delta lambda the whole square divided by E10 minus E20, and this is equal to delta lambda the whole square divided by E1 minus E2. So this is the answer. This is the end of this video. Thanks for watching this channel.